Okay, so several people have asked me how to use the first kinematics equation to solve for time. So I figured I'd make a video on it. So say you're using the first kinematic equations and the only unknown is time, then plugging, for example, these sample numbers here, you're going to have something like this, and the first thing that you need to do is to rearrange your equation so that you have 0 on one side. And this is a quadratic. We have a term, a b term, and a c term. So once you have the equation rearranged with a 0 on one side, you can go to your graphing calculator, go to y equals, and then you have to enter in this equation. We don't have a t, but you can just use x, that's fine. And obviously you're going to want to use whatever real numbers the problem are involving. These are just the sample numbers to show you how to do it. So we have it entered. Hit enter. Then go to graph. Alright, if you don't see the intercepts, then just change the zoom a little bit. They're there somewhere. But we can see we have an intercept there and we have an intercept there. Now you have to think about what the problem's requiring for. Usually there's only one positive time intercept, but sometimes there's two. And that's going to correspond to how many times during the problem does it reach that displacement that you entered in. So here, if you start out with a negative initial velocity, you're only going to have one time, one real time, one positive time where you have a negative displacement. But there's other scenarios that you can see where you reach the same height twice, once on the way up and then once on the way down. So let's just say we only have one positive time. We obviously want that one. Then you're going to go to second, calc, 2 for 0, and we're going to have to hit a left bound here, and then it's going to take me a little while. The emulator's kind of slow. Okay, so we've crossed it, and then a right bound, and hit enter again, and then one more enter, and then there. So you see that x equals 3.38. So that's our solution. And what does that mean? That actually means t equals 3.3835 whatever seconds. And why did this work? Because it's saying, well, this time causes this equation to have a y of 0. Right? Think about what we entered in. We said y equals this. We want to know when that y equals 0, that happens right here at the x-axis, and the calculator told us that one of the times that's true is when t equals, or in this equation, x has this value. And remember, you don't have to use this method. You can always use the quadratic formula. Dr. Holt also put up a video how you can program your calculator to solve quadratics, but this is just way I think everybody should know how to use it because it's so fast and simple. But hopefully that's clear, and just email me if you have any questions.